we'll be starting. We'll get people a bit. Sounds great. We'll give people a bit of time, and in a moment we'll be starting. The first question: yes, this is AI. I love how DALL-E is creating the images, and there will be some of them during the presentation. It is very, very good. And the truth is, OK, 35 minutes. So I do not have, OK, I have 35 minutes. It probably will be around 40 minutes because I have a lot of slides. So I assume the time is for me. Let's see what time we have, because I don't want, 10:45. So we will be able to start. If somebody is late, unfortunately, we probably do not have time for waiting for those people, because I have a lot of slides. You will see in the moment. JVM in the age of AI. What happened? OK, let's start again, because there is sometimes a problem. OK, right now, we are here. Probably everybody heard about the AI. Everybody tried to be an expert in AI. I'm probably not an expert. I'm not trying to be. So I will be talking about something I'm quite capable. I think I'm quite capable of. So I will be talking about the JVM. Because a lot of interesting things is happening in the JVM space in connection to AI. All in the mildly connection that we can just put under that umbrella. And a bit of context. OK, it's interesting. I do not see the slide. However, slide is here. So there is some kind of strange Mac thing. OK, right now it's here, because I've been still seeing the first slide. However, OK, it's working right now. Nice to meet you. Artur Skowroński. I'm working as a head of Java Kotlin development in the Virtus Lab company from Poland. You can know Virtus Lab from Scala. Do I have any Scala user here? OK, do you like Scala? It's all right. It's all right. We are currently the steward of the language. So good to hear that you are the steward of the language. And so whenever you are seeing the new Scala release, you can count it will be delivered by us. It's very interesting to be on that side of the language creation. I do not have much connection with Scala. The truth is, I'm, like I mentioned, head of the Java Kotlin development department. So I'm mostly involved in the JVM itself, Java Kotlin, however, not Scala. We have far better people in Scala in our company. You can't believe me. OK, so let's see what is happening to those slides. Wait a second. Because there is something strange happening there. However, we'll manage. You will see we'll manage. OK, I'm also an author of the JVM weekly newsletter. Whenever I'm trying to keep with everything that is happening in the industry and share with the people who are interested. So if you want, there will be a QR code at the end. As things similar to what I will be talking today are covered each week. OK, so that was the introduction. Now it's time to talk about the AI, because we need to start first define what we'll be even talking about. Because you can imagine, nowadays, everybody tries to be AI expert. I already mentioned that. Every business wants to go into that space. Mostly, I'm working for the software house, so I know. They do not know what they really want. So it's not the true discussion, however close. That's why I wanted to start with short introduction, what I will be talking about and what I won't be talking about. Oh my God, why those slides are not switching in that mode. Wait a moment, maybe we'll do this like that then, because there are some problems when I'm moving the slides and they are not showing up. Play in window, it should work as well. And maybe it won't be that. OK, it's probably quite visible right now, and I will have more control. Yeah, now it's fluid. OK, the first thing, we won't be talking about using LLM through API, LangChain4j, semantic kernel, string AI, things like that. It's not something that we'll be covering during that presentation. Also about the data engineering, not that presentation. Also know about the model development. Once again, not that presentation, because we cannot cover everything. So what we'll be talking about today, we will be talking about, oh my God, what is happening there? Why the slides are right now. OK, what we'll be talking about will be, maybe I won't be using the clicker, maybe that's the clicker problem. We'll be talking about the usage and inference from existing models, and mainly about the GPU programming. However, I know that, OK, oh my God. So It's probably due to projector. However, once again, we can go that way. Maybe it will be working better because there are some interesting problems here. Okay, mostly about the GPU programming. However, if I would told you that we'll be talking about GPU programming, nobody would come, so AI in the title. Now, it works, 2024, we need to, you cannot change the game, so we need to play the game. It will be helicopter view. Any topic won't be, there will be no topic that will be described very deeply. However, I will try to give you a broader picture, and I have 30 minutes for that, so it will be all right. Because I have 139 slides and 45 minutes, important thing, if you blink, you will be done. So please, don't turn your back, don't all look away, and don't blink, because you'll just miss it. Okay. After the introduction, and I already lost the 5 minutes for that, a bit of theory. Because whenever we are talking about the model inference, we are talking about the process of, when model is created, the model is trained using some pre-existing data. It's machine learning 101, that is used, the model creation process is finding some connection between those data, looking for the particular patterns, creating the fixed models, and that's the part about the only part about the model creation we're here today. And when we have a already existing model, we are providing it with new data, and model is doing something that is called inference, resulting in prediction. And inference, the truth is, it looks like that we are just passing the data layer by layer through all the model layers, doing the computation, mostly matrix one, and final result is some kind of the prediction. And this prediction can be a new version of image, it can be text classification, new token in the sentence, things like that. Because what machine learning models are doing, they are doing the prediction. And in practice, mostly those inference frameworks, those inference projects are implemented using the pre-existing frameworks, like, for example, TensorFlow. However, there is far more than them. That's why for TensorFlow, whenever people are importing the TensorFlow, they are thinking they are doing machine learning. They are probably not. However, that's just programmers nowadays. Other popular projects are Keras, scikit-learn, PyTorch, TensorFlow, as mentioned. Each of those has a bit different model file. We won't be covering difference between them today because we don't have time for that. However, what is important, each of those is in Python. So today, everybody seems to be eager to learn Python. And this will bring us the first idea that we could possibly have, because like we already mentioned, all of the project, all the ecosystem is currently going into the Python direction. So maybe we are able to use that pre-existing libraries that were created over the ages using the JVM. And the approach for that is so-called GraalVM. Did anybody heard about the GraalVM? Okay, have you opportunity to use it? Yeah. So we have some users. GraalVM is mostly understood as a way of creating native images, so building faster, smaller, linear applications. That's how they advertise the project nowadays. However, it's much more interesting than that if you go a bit deeper. Because the original paper that was the basis for creation of the project is called One VM to Rule Them All. So apart of being the nice Lord of the Ring reference, I love it. We have also a pretty interesting concept coming from it. Because we have JVM. And on the JVM, so Java Virtual Machine, we have multiple languages. We have Kotlin, we have Scala, we have Groovy. Each of those is kind of the syntax sugar over what JVM is able to deliver. And I know that Scala people do not like when I'm calling their language syntax sugar. It is what it is. Yeah. So GraalVM is a concept. If we can have already a lot of different languages over the JVM, maybe we'll be able to have the virtual machines that will be able to handle all the languages. And that's the concept behind the GraalVM, and they are currently pretty good at that because they have support for a lot of different languages, also through the Sulong project for the C-based languages, so they are getting there. However, the part of the project that we are the most interesting, which is most interesting for us today, is so-called truffle. It was delivered through the self-optimizing ASTER interpreter paper. And idea behind truffle is if we have Graal compiler, because the main deliverer of the Graal is the Graal virtual machine is Graal compiler, so kind of the standalone JIT, we can have different language interpreters that we are able to run as a dependency of our virtual machine. In practice, it looks that these language interpreters, they can be GraalPy, it can be GraalJS, GraalArabi, Express, so Java in Java, a lot of different ones. And it looks that, for example, if we have, I hope you see that, if we have our Java application, we can just eval a bit of Python and get the results and use it in our application. So we are able to have the standalone Python interpreter run over the Java virtual machine through the GraalPy project. Of course, it's never that easy. Because even in the context when we are able, because Python, whenever people are saying they are using Python, mostly they are using the C++. Because why Python is popular? Because it has quite nice interface to all those powerful libraries that are running on the very hefty hardware. And Python is quite good in running those. So the problem is that even if we are able to run strictly on Python, the real powers in the C++ extensions and C++ libraries that are used beneath. And while GraalVM is able, in the experimental phase, to run those native extensions, native modules, that's something that is currently possible, and the support is better and better in each truffle release. This is the list of the modules that are available from since March this year. So finally, we have Keras, we have Python, TensorFlow, right now is also a PyTorch, so it's possible to run those with all the dependencies. However, it's in the experimental phase, and what's more, the compatibility of package is still not there yet, because half the packages, most popular packages, is compatible. However, we still have the hefty list of things that are not compatible, mostly those that are C-related. Because to have something C-related compatible with the GraalVM and GraalPy, it needs to be precompiled, delivered, and each version needs to be once again precompiled by Sulong. So this LLM compiler. Currently, they are thinking about making it a bit more automatic and working on making the solution more stable. I was talking with the team on the DevOps, so it's getting there. However, unfortunately, it's possible to reuse all that Python stuff. It's probably not the best. It's quick, however, not the best solution. Yeah, so shortcuts don't help here. Okay, however, let's start to think, so Python is not the way we can work right now, maybe in the future, and possibly that's probably the best possible way to have the future. It's possibly very good solution for the future, not for now. So let's talk about the inference of model from the pure Java. Because right now, they are just frameworks. So we can have multiple of different frameworks created for the Java community, and we have TensorFlow version, Tribuo, DeepNet, Deep Lava Java library, things like that. Because, like I said, it's just the framework. However, each of those frameworks is just its own thing, because we do not have standards. And everybody knows that XKCD comics here. Probably everybody have heard it at least one time. The truth is, in Java community, in past it worked quite well. We are on the EclipseCon. We are on the Eclipse conference. So, Jakarta is stuff like that. We have those standards. They are working quite fine. We have JPA. We have JDBC. We have JAX-RS. We have Servers API, and a lot of different. Each of those have a different vendors. Okay. Okay, thank you very much. Thank you for the tip. Okay, so we have different APIs that are available for us and have different implementations. So for Java, it worked in the past. However, and we also tried to do that with the machine learning because we have JSR381 Visual Recognition API. Unfortunately, and we have even some implementation of it. We have DeepNet, we have Deep Java library. So there is project like that, Java specification request. However, the problem with it is that it was created too early, because just look on the list of examples. We have hello world, we have linear regression, we have image classification, handwriting digital recognition, something that probably was very interesting for people in the past. But nowadays, everybody is talking about the tokens, images, things like that, not about the classification. So it's just a bit premature. That's why nobody is interested anymore in that project. That's the truth. I'm counting on the fact that maybe I will learn today that there will be some nice Jakarta standard for that. We will see maybe in the future. However, it's probably changing too much. And that's the other problem, that this space is changing a lot each month, each week. So it's very hard to create standards for something that quickly changing. Even for different RDC, each of the projects has a bit different model, because each of them has a different characteristic. We have some compatibility layers. It's called ON and X. Unfortunately, not that many people want to use them, because we want to be very quick. Whenever we are using ML application, we want to be very quick, because performance is the key here. And we have two different kinds of the performance complexities when we are talking about the ML application. The first of them is computational complexity. So each layer requires needs to perform a vast number of mathematical operations, such as matrix multiplications. And the bigger the image model is, the more layer it has, the greater number of such operations. Apart of that, there is also a problem with model size. That models that have many layers are taking a lot of memory, and storing and processing such large number of weights, so parameters of the model, requires a huge amount of memory resources, and not only covering the sheer amount of the memory, but also ability to feed application very quickly with that memory. So the first optimization that we can have is the half floats coming from the project Valhalla. And to understand what half floats are, first let's discuss the standard floats. In standard floating points, we have 32 bits, and 1 bit is for the sign, 8 bit is for the exponential range, how big is the biggest integer float and how small is the smallest float. And also we have precision, so how many between 1 and 2, how many different numbers we can pack. And for the 16 bits, also half floats, we are having still 1 bit for the sign, 5 bits for the exponent, so once again range. We have just smaller numbers. We do not have the same range that we have in 32 bits floats, but also precision is smaller. So between 1 and 2, we can have smaller amount of numbers. However, for the machine learning application, it's fine. Mostly, because they do not need that amount of precision. And currently, that's the repo from the project Valhalla. As you see, they are pull requests connected to exactly that feature. So they are currently trying to merge it. It's from the end of September, probably by now, some of them could be merged. This is the repository of the project Valhalla. Of course, that's not the silver bullet. So just having the smaller amount of the memory is not enough, because like I mentioned, more important is ability to fit that memory to application very, very quickly. And now we are coming to yet another part of that presentation about the native code. Because I had already joked that Java programmers are better because Python programmers are just glorious, the interpreter layer over the C++. The truth is that we know that we also have our own C++ background. And we also use a lot of C++, because I already mentioned the projects that are doing inference in Java. This is the most popular one, at least one of the most popular ones, deep learning for J. And as you see, they are using C++ code via the JNI to just feed the memory. So in truth, we are just having the thin layer of Java, and most interesting stuff is happening on the C layer. Apart of that, there's also something mentioned called ND arrays, and I will be right back talking about it, because it will be interesting as well. And quick intro to JNI. JNI starts the Java native interface, so a framework that allows Java code running on the Java virtual machine and interact with the native applications. It was typically in the past used in the application that needed to do something very efficiently, not the case anymore in most situations because Java is very efficient. The JVM is pretty efficient. However, also interaction with the system-specific libraries and low-level hardware. That lower hardware portion is very important. When Java was introduced in 1997, it was just Java 1.1, so the MacBooks look like that. You know what? I expected it to look far worse. It was still quite nice. However, like we mentioned, Java JNE is pretty old standard, so currently we are getting into the so-called Project Panama. And Project Panama is bringing a lot of different replacement for the JNI, like foreign function memory API, a linker API, interconnectability, improved performance for the native calls. It's bringing the JNI for the 2024 century, 2024 year, because we are using it more and more than we have been using in the past. And especially Vector API, so the last one, is apart of just having the nice replacement for the JNI, Vector API is something very, very interesting for us. Because that's the first time in that presentation when I need to mention GPU on the slide, because most of the machine learning workloads is happening on the GPU. However, that's why in NVIDIA had such a bump in stock. You can see there that was, they had their time of their lives with their cryptocurrencies. However, currently it's crazy. However, still, probably most of our machines and most of our servers is mostly CPU-based. What does it mean in practice? In practice, that means that we are just not having access to very powerful GPU. We are mostly running everything on the CPU. And they are model. However, whenever we want to try some models, we have some capabilities. And I will use the example of the Meta Llama 3. So the most capable openly available LLM to date from Facebook, how they mention, that's how they advertise it. It's very good. It's very good. And as it's open, it created the ecosystem for quite nice tools. And what is probably the most interesting thing that we are achieved through Llama is the fact that we created as a community a lot of different ways to run it on the CPU. And probably the most important project that ever happened in that ecosystem is Llama CPP. So it's just the 700 lines of code written in the C++ that allows to run all those models having particular weights in the standard CPU, using the standard CPU. In comparison to this hefty GPU frameworks like the TensorFlow, for example, Llama CPP is able to because machine learning is mostly computation, mostly vector, mostly matrix computation, and it's not very complex. You have a lot of data, a lot of processing, however, everything is not very complex. So in 700 lines of the C++, it was possible to create the whole solution that is able to do inference. And it is very optimized for the CPU. I'm not optimized, like for example, those new NVIDIA cards, however, it's working quite fine. Because like I mentioned, it's just the computation layer by layer, and C++ was able to deliver it pretty nicely. So now we are able to replace this GPU part, TensorFlow part, with the standard just file of the Llama CPP, and being able to do the inference in that CPU-based application. And this is just a piece of code. And if there is a piece of code, we can do the same trick in Java. And the first thing we can do is just create some JNI bindings for the Llama CPP. We can reuse that library that was already created in our Java application. And this is the project that already delivers that. However, it's probably just the part of the story, because they are crazy people in the community, and one of them is Alfonso from the GraalVM team, and he created the Llama 2 and then Llama 3.java. So project, when he ported that code, written in C++, is just the 700 lines. In Java, it's, if I remember, okay, it's 2,000 lines, so a bit bigger amount than the standard C++ implementation. Still, 2,000 lines, single fine, that is called Llama 3 Java, that is able to do the inference on the CPU using Java. Of course, this is not the only project. There is also a project from guy behind Jake Luciani, guy behind the Cassandra, who created JLama, a bit more complex, feature-heavy solution that is working the similar way, also doing the inference for the CPU. And he was saying that it's quicker than the C++ version. So whenever somebody tells you that Java is slow, it is not. Still, the magic of performance of those solutions is once again coming from Project Valhalla and Panama together and so-called themed. Because you need to write the application in a pretty particular way to be able to get that speed. And what is bringing us there is so-called themed model. Because standard calculation on the CPU works in the single input, single data model. So each instruction, each piece of data needs to be passed to instruction needs to be calculated, and the result needs to be gathered. And it's happening for each of the instructions. Single input, multiple data, is just batching for the CPU. So CPU, if you are there, it's doing exactly the same instruction or different pieces of data. It's able to batch them and deliver results pretty quickly. And truth is that JVM is doing that for us already, JIT compiler, because whenever we are running the standard loop, it's able to, okay, we are doing the same instruction on different pieces of data. Probably we are able to optimize it a bit. Still, we do not have currently, since now we do not have stable option to be in control out of vectorization, so it's just done by the JIT. JIT is doing that pretty nicely. However, for the machine learning application, we want to have the far better control, and currently there is one option to do that. It's so-called Vector API. Vector API is currently in the 8 incubator, so it's incubating for the several version of the JDK. Because it's waiting currently for the stable release of Valhalla. It needs to be incubated until Valhalla will be ready. However, it's such useful for the current workloads that people are using it in the production application even while it's still in the incubating phase. Because we are still waiting for Valhalla, we probably wait a bit more. Because apart of those LLM-based frameworks that do inference on the LLM, there's also project, for example, JVector. JVector is advanced embedded vector search engine, also used in Cassandra as a part of the data stacks AstraDB. So they are using that in production. It's not included yet in the modern Cassandra. However, they are getting there. So it's possible that Cassandra will be using incubating features in the production soon. This is a very interesting story, what is happening in that particular API. However, it's just proving that it's very, very needed and very, very useful. So, okay. Now we have covered the part connected to memory. It's time to focus on the computational complexity, because we are having interesting stuff there as well. As we already mentioned, for the machine learning, in the production, we are not doing CPU-intensive tasks. We are mostly using the GPU and different hardware. For example, I do not know if you have ever heard that, for example, Azul created in 2006 and even earlier special CPU made particularly for Java. It never got a lot of traction. However, most of the intensive workloads that are happening in today's community, they are done on the special hardware. So GPU, tensor units, or even FPGA that are custom made for the particular calculation. It was a thing during the cryptocurrency craze, and it is happening right now. So apart of being able to deliver application for the CPU itself, we currently have far more options. And here will be, and for that, we need to have a different computational model. That's the biggest problem. So here we'll have a very simplified example, because that's not how the GPU works. However, in theory, that's how we can approximate how they work. Because whenever we are running any calculation on the GPU, first, let's look it looks on the CPU. Like we already mentioned, we have symped, we are able to do the batching. However, still, one core, one instruction. The instruction can have multiple data, however, it is just one instruction, and we are limited in throughput here. For GPU, so we are just having instruction result, and it is taken piece by piece. For the GPU, it works the same, however, we have far more cores. We have a lot of those cores, and they are custom-made for the parallel processing, because they were made to calculate each pixel of our application. So those lots of cores is able to do the work in the more parallel way. And in machine learning models, each computation is pretty small. However, you have just a lot of those. So GPU are very, very good for that. Apart of the one problem, we need to be able to deliver those data to that GPU, to be able to do those computations. And for that, there's special model, a special language called CUDA, special model called CUDA. It's probably the most popular one. There's more of those. However, CUDA is the most popular one. And it introduced the concept of so-called ND-grid. ND-grid is multi-dimensional grid of threads used for parallel computation on GPU. It works in the way that developers are just calculating the, pre-create the array of all the data that will be necessary. And there, the whole array is packed to the GPU, and GPU is responsible for just taking it piece by piece by its own memory, because the memory access is the most painful part of the whole process. Apart of that, this ND-grid is full of so-called kernels, and kernel is a piece of code that is executed by hundreds or thousands of threads simultaneously. Each thread runs the same code, but operates on different data. So this way, GPU is able, using that model, I know, is able to easily this model, okay, I lost my flow. GPU is able to easily process that hefty data sets. And Java is doing that for years, because we currently have a lot of GPU computation on Java. However, once again, we are doing that through JNI. And probably you are not able to see it. However, it's quite similar model with what we already have in GraalPy. Because what we have there, we are just defined CUDA kernel as a string written in C++, and passing it to our GPU. This way, we are able to give the instruction what needs to be done with the data. Not something that we want to see on our production code, however, it is what it is. So there were multiple projects that were allowing us to introduce a kernel expressed in Java itself. The first popular one was Aparapi and Rootbar, and we were able to create kernels directly in the Java code. However, they were just Intel approach, didn't have quick access to memory. They were just connected to one of the ecosystem, not something that flourished a lot. Because additionally, they needed to use just the proprietary data types, not something that, even if it was just created in Java, we didn't have access to the ND-grid. We needed to use their data model, not something very useful. However, then people from JDK decided, okay, it's time to start to be a bit better in that. So they introduced the Project Sumatra. And Project Sumatra was reusing one of the concepts that are already here. Because parallel processing, whenever we are talking about the JDK, I know what you have in mind when we are talking about the parallel processing. Stream parallel. And stream parallel was, okay, we have nice concept of the parallelization of the JDK. Maybe we will be able to also reuse it for our GPU programming. And because it's parallel, maybe we can just use this to move our parallelization to the GPU. And that was the Project Sumatra approach. And it was working on the GraalVM. So GraalVM is coming once again. And GraalVM was compiling the code to the CUDA and the OpenCL, so AMD approach. However, like I mentioned, data transfer was the pain, because there was just too many hops between the main memory and the GPU memory. And also, as Sumatra was mostly based on the GraalVM, they were just two projects that were too interconnected. It was not worth pursuing it any longer together. Do I'm able to have 5 more minutes, or it will be? Okay, thank you very much. Because I do not want to be that quick, because we are having quite interesting part here. We are wrapping there, however, I have a quite interesting part. TornadoVM. And TornadoVM is very interesting project that are bringing us closer to real calculation on the GPU on the Java virtual machine. because it introduced us with a special virtual machine that is fork of the GraalVM tailor-made for the GPU with the whole computation process that is coming with that. Because the API introduced tasks, so ability to just create the kernel. Task is something like kernel. We can also create the tasks using annotations, so automatically recreate the, changing the particular function into parallel for the parallel execution. Also, we are able to create so-called task graph. And task graph is probably interesting there because we can have join multiple tasks into the some kind of the graph that provide all the necessary dependencies between tasks. So we can say which task depends on other tasks, and pass it direct to the TornadoVM. And TornadoVM, like any good SQL server and a good database, is analyzing our query, is optimizing it, deciding which part should be run parallel, which part should be run on the CPU, knowing what is happening in the hardware. It also have execution engine that is just distributing the decisions between different kinds of the hardware, and Tornado JIT compiler that is using the GraalVM JIT compiler. Like I said, it's a fork of the project, being able to calculate the code to the CUDA, OpenCL, PTX, and any other format that we want. So it's just joining together all those projects that were happening in the past and creating the common, I would say, end-to-end solution for that. Last week they informed that they are, for example, able to run JLlama on itself. Because there were problems in the past, currently they are able to run Llama CPP and JLlama on their own stack. So that's a very interesting project that is currently developing very rapidly. However, there's also, if you want, there's TornadoVM program explained on the Fuji article. It's a very good one. However, the last, okay, we can make the screen. However, there is just yet last thing I wanted to talk about is HAT and Project Babylon. And HAT means Heterogeneous Accelerated Toolkit, and it was announced last year during the JVM Language Summit, so this is official project of the JVM team. And what they are going to bring? They are going to bring ND range. They are going to bring foreign function and memory access data wrappers, and also something that is called code reflection. And code reflection is a very interesting concept because current reflection is able us to just, code reflection is extension of Java reflection that allows access to symbolic representation of Java code, such as method bodies and lambda expression and runtime. This makes it possible to programmatically manipulate Java code. Yeah, abstract, it's delivery tag. It's something that is coming between the Java bytecode and the abstract syntax tree. So because abstract syntax tree have too many details, so it's not easy to use. No, it's not easy to use programmatically. Bytecode just do not have necessary information. Code models. So concept that is coming with the code reflection. That's the part that allows the developers simply go piece by piece for the pieces by the instruction in the code and transfer it to the other language. And it looks in the way that JDK is able to just, on the runtime, knowing that, for example, I have access to the GPU, deliver code for the GPU. So the vendor native runtime code. And currently, there's already some very nice results of the project because Paul Sandoz migrated the Triton language, at least part of it, that was the project of the OpenAI to Java runtime using the code reflection. So this is something that probably will be the future. So we'll have the access to the very fast memory through memory segments through the Panama. We'll have access to the code reflection that will allow programmers to translate code on the fly. And this is something that will happen in the few years because on the current JVM Language Summit in August, there was just the modest update of the project. It's not something it's something we can start playing with. However, they are doing a lot of interesting work. However, it's not there yet. Maybe in a few years we'll be able to see, probably after Valhalla. So wrapping everything, because I already passed my time. Panama and Valhalla themed, we are ready to go. It's incubator, however, everybody is using it. You also can use it. Valhalla have floats, maybe in the future. It could probably be merged soon. However, I do not see any official job for that. GraalPy, it's there, you can use it. However, I do not suggest that it will be working fine on production. It can be anything. JQuda is with us for years, so just simply running the C count, we can do that. Sumatra, it will never happen. It's not dead yet. However, we shouldn't expect any future for it. TornadoVM almost there because they are doing very good work, and we are last week, like I mentioned, just after my DevOps presentation, they were able to deliver the JLLM support. And Valhalla and Babylon is the future. However, I don't know when the future will come. And I know it was very hectic. I know it was very long. I hope you like it. And now, thank you, and waiting for the question if there are any. Do you have any question? Is everything clear, or it was too much to process in short amount of time? Okay, if there are not, I will be there after the presentation, and probably